So now we're going to lead into our water management panel, which will be moderated by Henry Lazenby, who is with the Northern Miner Group. He is an international journalist with over 10 years of experience, heading up a North America-focused resource news desk for different multinational media houses. Back in native South Africa, he was award-winning community journalist before the B2B media market exposed him to mining. He was a secondman to Toronto, Canada, soon became permanent, and frequent visits to mining and exploration sites and participating in industry conferences. Henry also specializes in covering the North American international mineral exploration, mining, and metals markets. He is based out of Vancouver these days, so we're expanding coast to coast here. And he writes and produces multimedia content for mining.com and the Northern Miner. I'm pleased to present to you Henry Lazenby.
Good day, Robert. Thank you very much. It's my pleasure to moderate this featured panel on water management. All right, so joining me today are three distinguished experts in the water management field. First up, we have Dr. Monique Simair, CEO and Principal Scientist of Maven Water and Environment. Dr. Simair is recognized internationally as a disruptive technology innovator in the water treatment sector. A postdoctoral biochemist by training, she has developed semi-passive water treatment technologies that are used at mines globally. Some notable achievements include designing the first full-scale gravel bed bioreactor in operation at a mine in Canada and implementing the first constructed wetland treatment system demonstrations at mines in the Yukon and in British Columbia. They've been operating since 2014. Monique has built two multi-million-dollar clean tech companies focused on semi-passive water treatment systems, and she has also been named as Canada's 2021 Eco Impact Awardee by Eco Canada. She has also been named by Profit Magazine as one of Canada's future entrepreneurial leaders, to Chatelain's W100 Women Entrepreneurs listing, the University of Saskatchewan's Alumni of Influence, among multiple other awards for technology innovation and leadership. AJ MacDonald of Integrated Sustainability joined us as well. AJ is the Vice President of Engineering at the firm, which is a specialist advisory and infrastructure delivery company. He is a versatile technical professional specializing in water and wastewater treatment management, including sourcing from the environment, storage and containment, distribution and conveyance and treatment facilities. His expertise include extensive involvement in water management process and mechanical engineering with supporting skills in project management, package engineering, construction management, and commissioning. AJ's professional experience includes over 15 years of engineering research and project delivery in both the industrial and municipal sectors. And then last but not least, we've got Dr. Sylvie St. Jean, Director for Environment and Reclamation with Osisko Development. Dr. St. Jean has over 20 years of experience in the mining space with a focus on water management. Dr. St. Jean started her career as a research scientist for the Government of Canada, where she was involved in developing an alternative to the fish survey for the Canadian Metal Mining Environmental Effect Monitoring Program. During her tenure at the government, Dr. St. Jean received the Young Canadian Scientist Award. She then joined the industry and has over 15 years operational experience at various sites. Except for the 5 years she spent as a Canadian and USA compliance manager in the energy sector, Dr. St. Jean has worked for mines such as Teck Resources, Ambatovi in Africa, New Gold's Rainy River mine, and now Osisko Development. Amongst her achievements, she led the first mine to obtain an environmental certificate for an open pit mine in a world hotspot for biodiversity under the rigorous IFC 2012 standards. Her expertise and experience is now put in contribution on the water management strategy for the design of the Caribou Gold Project in British Columbia, with a focus on minimizing water contamination and water intake by maximizing reduction at the source. With that, I bid you a hearty welcome to the panelists. All right, so let's jump in. I'd like to start this conversation by asking Dr. St. Jean, to kindly give us a bit of a 40,000-foot overview of how, perhaps from a regulatory standpoint, the water management landscape has evolved over the past decade. And perhaps as a quick follow-up to that, you know, how the industry has responded to those developments.
Well, thank you very much for the invitation to speak in such awesome company with my colleagues here. To answer your question, the water quality criteria in the last 5 to 8 years have significantly tightened, particularly at the provincial level, to the point that now in some jurisdiction we treat to almost, or if not better, than drinking water quality. And that is obviously to protect wildlife in the receiving environment. And it's the same thing as well on the water quantity. It used to be that, you know, you need water, you stick a pump in a river, you pump the water, you have too much water, you discharge it, and that's as much as you thought about it. But now you really the amount of water you can take is regulated, as well as how many discharges you are allowed to have, the quality of the water that you have to discharge, and when and how much you can discharge is highly regulated. So and these developments really it's mostly the last 5 to 8 years. So how did the mining industry react? Well, some of them, it's been variable. Some of them, I'm thinking of my colleagues at Tech, Newmount, Alamo, we just saw, adapted immediately, and they're, you know, making water management a big part of their program. Some did not. Some continue to develop their mine based on the needs of mining operation and milling operation, and then they try to retrofit the water management or the water treatment when that is all done. So they develop their mine, and then it's okay, this is the water we have, and this is the water quality we need to reach. So how can we do that? So retrofitting is enormously expensive, and it's not always successful. And in the last, you know, 5 to 6 years, there's been a few mines that had to shut down temporarily due to water management issues. So it's really, really important. When I think of that, Osisko, the company I work with, our reaction to that was to include the water management team at the table at the very beginning when we start designing projects. So water management is at the table with the mining guys, with the mill, with construction, and we try to inform the design so it saves money, not only you know, by reducing our water quantity, by reducing the water we're using, we're also reducing the water we need to treat. So therefore, we're reducing the capex that's needed for construction, but also the opex during operation. And then when you think about what you're doing at the beginning of it, you can therefore plan it so it's a seamless transition to closure, and therefore your bonding is reduced. And then, like our previous speaker was saying, you're not treating for eternity your water. There's an end to it. I hope it answers your question.
Yes, it does, certainly. So what I'm gathering is that there's been a wholesale paradigm shift from the mining industry point of view in response to tightening regulations.
Yeah, if I can give an example of that in a more practical term, what we've done at Caribou is we've integrated those very principles. So we're reducing the amount of ore that we are sending to the mill by using an ore sorter. So then it's a concentrate that we send. So we have less ore to mill, less water demand, less water discharge. But we've also adapted, we decided to use a filter stack for obvious reasons. There's less water demand, but filter stack comes with their own challenge in terms of water quality. So we adapted the way we're going to deposit our filter stack such that we are significantly reducing the discharge or the release of constituent of concern. So then we don't have to build such an extensive water treatment. We don't have all this water management to do. And we've also looked at, there's a part of our water treatment that is using nanofiltration, and traditionally the reject of that retented, it's kind of a sludge. You either put it into your water ponds or your water sediment pond, or you truck it off site. So what we're looking at doing right now is transforming that retented so it doesn't create this loop of contamination, and reduces again our constituent of concern. And then Another thing we're doing, and that's just at the mill, there's a whole other suite of thing we're doing at the mine site itself. But another thing we're doing at the mill is reducing the source term. The best way to reduce how much water you have to manage and how much water you have to treat is to eliminate the source eliminate it at the source. And how can we mine differently? How can we mill differently? So we're reducing our footprint, so we have less water, less contaminant, and less water to treat.
Sure. Yeah, that's certainly useful. Thank you very much. I'd like to turn to Dr. Simair. First, may I ask you, where are you joining us from today? It seems like you must be out in the field.
Yes, sorry for my appearance, but yes, I'm out of the field right now. We're actually working on a couple of water treatment systems at a mine in Ontario at the moment, actually at Rainy River. So it's a little chilly out here. We're very dressed warmly, but I'm very happy to take this break and warm up.
Excellent.
Thanks
All
for having
well,
me.
There you have it.
Say hi to the gang for me.
Action is happening. All right, so Monique, I'd like to invite you as the creator of 2 multi-million-dollar clean tech companies. You certainly did see and grasp onto a gap in the market, perhaps created by regulatory enhancements or just by the market responding to, environmental consciousness. Could you please provide us with a bit of a more detailed overview of how your 2 multi-million companies have been created, what their key successes were and are, and we'll build the conversation from there.
Sure. So building on what Sylvie said, there is a lot of regulatory pressure on, specifically in mining, for water treatment. So as someone interested in water treatment technologies, it's an area that is a lot of opportunity for innovation, because there's more pressure to perform, there's more pressure to get cleaner water than any other industry out there right now. So seeing that in the mining sector, and also seeing that there's this gap between sometimes the science that exists and the technology and applications that are approved to be used, that's really where I thought, okay, there's an opportunity there, because the science says we can do these things, and so is the engineering, and we've got to just figure out how do we actually get these built and permitted. And so that is really where we work at Maven, and figuring out how do we implement things in ways that will not only treat the water, but in a way that can be address the risks that a regulator might have, or that can get the permits that are needed, be within the timelines that are needed, and also, of course, not using our projects and our clients as a science project. This has to be technology that is ready to go. So we also then built out pilot facilities at Maven. So we've got close to 10,000 square feet of pilot facilities and laboratories where we actually will test things out, pilot them. And then we've recently also built pilot units that can move around to the mine sites. And we have a few out here which is why we're outdoors, a few out here that we can test out things like treatment wetlands and bioreactors. And there's a real big pull for that from a few different ways. I think there's the regulatory pressure for better water quality, but there's also the ESG aspect of wanting to have lower carbon footprint, more sustainable technologies, less chemicals, less electricity used in your treatment processes. So that's part of the space that we fill, but also recognizing, I think one of the things that makes Maven quite unique is we don't just do only treatment wetlands or something like that. Like, we look at a wider range of treatment, and even though we don't do something like, say, for example, lime treatment or reverse osmosis or ion exchange, we partner with other companies that can do those things and bring together the active and the passive treatment. And I think this is something that we're going to see as a trend for at least the next decade in mine water treatment, is not using just one specific technology at a mine site, but blending together the different technologies to do what's best for the site, get the overall CapEx and OpEx wins, so to speak, as Sylvie was mentioning, decrease those costs. But combining those together, integrating those technologies can be quite difficult and requires really special skill sets. It's actually, we've collaborated with Integrated, who's on the call here, on a few projects like that, where being able to get together and say, okay, I know you do this and we do that, but how could we pull them together? And then And I think that's a cool thing about mine water treatment right now, especially, is there's a lot of collaborations happening to bring things together rather than siloing we maybe saw before.
Okay, well, that's certainly, congratulations, honestly, that's what I wanted to say. Perhaps just, I'm glad that you mentioned some of the technologies that you've been using, and I thought it's perhaps a good idea at this juncture to clarify some of the technical terms for our listeners. In researching, for this panel, I came across a few key words that, come up time and again, and they refer to active, semi-passive, and passive water treatment systems. Perhaps AJ, if you wouldn't mind to jump in here, could you please explain to us what the key differences are between these technologies, and perhaps also just distinguish, perhaps, as to, the difficulty of implementation and versus, technical complexity versus cost, permittability, and perhaps their effectiveness?
Sure, I'd love to. Yeah, that's a big question. So I'll do my best to do it in a amount of time, but yeah, and sorry, just off the top, I just want to say what an honor it is to be here with Doctors Simair and St. Jean. It's quite a group to be a part of, so thank you for that. But to answer your question, I think your listeners may be most familiar with active treatment, and this is not just something we use in mining. This would be in every water treatment. So, for example, even your domestic drinking water and wastewater treatment plants would normally be active treatment systems. And so what you'd be familiar with there would be a physical plant and process mechanical equipment and highly engineered structures, and essentially what we're doing in active treatment, but in fact in all treatment systems, would be managing, manipulating, and harnessing processes that help us condition water and remove or transform constituents of concern. So active treatment would be intensive with respect to electricity, with respect to equipment, with respect to operation and maintenance requirements. And that'd be what you'd be familiar with mining treatment plants. I think Monique mentioned lime treatment and high density sludge, and there's other types of plants, but those would be familiar to your listeners. Semi-passive, one way to think about these concepts, by the way, would be the intensity of operation and maintenance helps to think about it through that context as well. So the intensity of operation and maintenance does go down, but the site suitability and the site specificness of the system typically goes up as we get into more passive systems. And more passive systems, a semi-passive system may still use chemical injection, may still have electricity and some pumps and pipes, but generally it's a less capital intensive potentially, or less complex in terms of the amount of physical plant that is there. So you may see the same processes. We can use, for example, high pH metal precipitation, that type of thing, but we may be doing it in something that looks far more natural. So it could be built in ground or treatment in situ and this type of thing. And there's a number of technologies there that are either have some sort of hydraulic complexity or some sort of biogeochemical complexity as well. And then a passive system, and frankly, passive systems already exist in nature. Nature can by itself attenuate some things we would call parameters of concern. But a passive treatment system may be the lowest and very low operational and maintenance complexity. You may think of it as something, a walk away type of system you could walk away from, but it is very easy to overestimate the implementability of a passive system. And so in many cases, what we're focusing on from an engineering perspective would be either active or semi-passive systems. And the way we, another great sort of area of context to think of this in, and this, I was thinking of this as Dr. St. Jean was speaking there as well, is how we transition from active mining into post-closure treatment. And it's very important because chronologically, we're going to be doing more water treatment post-closure than we do during active mining. So in many cases, we'll design systems holistically so that we've got a viable solution from active mining into post-closure. And we may see, for example, transitioning from active treatment to semi-passive. And eventually everything becomes passive. on a long enough chronology, everything becomes passive. So what's economical and technically feasible during production may not be feasible later on. And Mr. McCluskey was saying in the last segment with the capital intensity of mining projects. And we have to really keep that in mind, because we need something that's feasible so that we have the ability to have environmental performance from active mining into post-closure. In many cases, that means we have to manipulate the amount of active treatment and transition towards something semi-passive. So,
excellent. Well, thank you very much
question,
for that
I
very
hope so.
useful analysis. Yes, no, I think it's exceptionally useful to understand the industry, you know, and I think the bottom line of what you've also been talking about is that it makes sense to miners' bottom lines, you know, to have good water management practices in place from start to finish in a mine project's life cycle. So just sticking with you for a second, AJ, how are technological advances changing the water management landscape? Are there perhaps new software suites, you know, to help with modeling, you know, tools such as AI, predictive management? Are there perhaps any of these kind of technological advances that's having a material impact in the water management industry?
Yeah, well, I think the answer is yes, of course. With respect to technological advances, again, the central theme is removing toxic constituents or transforming them to something less toxic. So it could be metals, could be toxic organics, could be non-metals or metalloids. But everything ends up back in the environment at some point. And what we're trying to do is manage the toxicity. There's different ways to do that. For example, for metals removal, what we do is we reduce the solubility of the metals. So we would transform dissolved metals, for example, into metal salts or manipulate the pH so that it becomes less soluble. What we're trying to do is get it out of solution and be able to separate from water. So the technological advancements, if this was 20 years ago, we'd be talking about how in Kimberley, BC, there was significant advancement in lime treatment for mine wastewaters. What's become really an industry standard in high density sludge. But of course, today we do see advancement. We see different types of, sticking with the example of metal precipitation, we see different types of precipitation reactions being used, many of them fully at commercial scale now. But for example, instead of using lime to create metal hydroxides, using sulfides to create metal sulfides that are much less soluble. And in fact, we have a plant permitted in BC just recently where we're using both high pH with lime and sulfide, and we're using an iron co-precipitation, so multiple types of precipitation. This type of thing we're seeing more and more of. There's other technologies that are being adapted from other industries or other sectors. So for example, we're using a lot of biological nitrification, denitrification systems. These have been adapted in large part from domestic wastewater treatment, where nutrient removal has become very important. And so there's good precedent in the previous decades for using these for domestic wastewater treatment. So that's of great interest in mining. There's ion exchange. BC's got one of the first ion exchange plants to remove selenium and use it as an electro reduction process for sludge management. These are all innovations right in Western Canada. So we do see a lot of that. With respect to software, again, there's adaptation of software from other sectors. So we're using BioWin and other domestic wastewater treatment softwares. We're using membrane systems, an example of the software we use, but also using membrane systems in mining is a technological advancement or adaptation. In many cases, in mining, when we're using membrane or advanced filtration processes, we have to keep in mind that in most industries, these were limited by high dissolved solids or high TDS. You could think of desalination, for example. In mining, the challenge is scaling potential. And so the precipitation modeling that we do, in some industries, we're doing it to prevent precipitation. We want to prevent scaling and things like that. So we use thermodynamic electrolyte models. In mining, we're trying to encourage precipitation. So that's the adaptation we have to do. And we have to understand how to use these tools when we adapt them into mining for the purpose we need them for. So I'd say great examples of both treatment technology and the software But in each case, we have to know how to adapt them properly for our purposes.
All right. Yeah, thank you very much for that. So I want to turn back to you, Dr. Simair. You have mentioned ESG as being a partial driver for miners, engaging more with regard to implementing good water management strategies. Could you perhaps just share some more perspective, on how, from your view, it is translating through as part of mining companies' sustainable infrastructure frameworks? And perhaps as a second part to that, I know that you've recently been quite active in British Columbia, assisting companies with navigating the technology readiness assessment requirement. Could you perhaps also just talk a bit about that, what that is, and how you assisted clients in navigating that requirement? Sure.
Well, to get the first part a little bit with the ESG is we find we're getting contacted more. It used to be simply about, or maybe not simply, but specifically about water treatment. We get contacted, and now we get contacted even from more of the ESG groups with the mines, because most mines have a person or a whole team involved in that, and they're wondering how they could decrease their carbon footprint by switching. For example, if high density sludge uses a lot of lime, and lime can have a lot of CO2 associated with it. And so they're looking at how could they decrease that carbon footprint, because many have overall company goals for decreasing carbon footprint. And if water treatment is one way they can go about that, that helps on a few fronts. It might not mean switching their entire water treatment over, but even if a fraction of the water could get changed from an active treatment system to a semi-passive, or there's so many different words that get used interchangeably. So I'll just say, AJ did a great job describing the differences, but I also say, you have to really look at what the actual technology is, because some people will interchange semi-passive and passive or enhanced passive, many different words, but some of these slightly more environmentally sustainable technologies, and what that can do, and this ties into the technology readiness areas. In BC, they've released some new technology readiness assessment guidance documents. And these are brand new. They just came out about 2 months ago, maybe 3 months ago. And what they do is they explain, using the technology readiness levels that is commonplace in all innovation sectors. So if you look at venture capital or vaccine development, they use technology readiness levels to assess where things are at. It was developed by NASA back in the 1970s and adopted by everyone else since. And so what they did was they took ISED, Innovation, Science and Economic Development Canada's technology readiness levels, the federal ones, and they adapted them slightly to match up to the regulatory steps to get water treatment approved for major mines in BC. And I think this is just fantastic, because it gives common language to talk about where a technology might be. Now, active treatment technology addresses site-specific uncertainty or variation in climate, variation chemistries by applying energy, by applying electricity or reagents and chemicals. So they tend to come in at a very high technology readiness level. Whereas the more semi-passive, passive treatment actually has to be designed specific to accommodate that variation, because it's not going to use, say, heat to keep the water consistent temperature for treatment. It needs to be capable of dealing with the fluctuations. And that means that no matter what, no matter how many places something like a gravel bed reactor or wetland gets demonstrated, it's still going to come in at a lower level when you try to apply it in a new site. So you're going to need to go through more testing, more piloting, more demonstration. And that's where it's a great opportunity to put a smaller scale or a partial scale on site as part of an ESG initiative, paired up with the active treatment. It gives a chance to prove the technology up, get it through those readiness levels, so that when it does come time for closure or other phases of mine life, you can implement and you have all the information that you need. And you also get the ESG side at the same time.
All right.
Now, it also ties into your question about, so you talk about the artificial intelligence. I'll try to keep it quick here, but one innovation coming along too is remote monitoring. So if we want to go more and more passive, one of the things is access to these systems, the remote monitoring, and the amount of data that we need to have certainty of performance or risks. So I think we're going to see an influx of remote monitoring, big data, and AI systems coming into these. I mean, we're looking a decade out there, but the remote monitoring is already something that we're doing, remote, change of reagents and flows and stuff. So, yeah.
Okay, well, thank you. And then, Dr. Shajan, looking forward, what do you expect the dominant water treatment system will be in about a decade's time?
Hopefully it's going to be more thoughtful and it's going to be site specific. Not every site can use a nanofiltration system or biochemical reactor, although I can't see any site who can't use a biochemical reactor, if you ask me. But it depends on how much water you need to treat, what volume you have. Passive and semi-passive sometimes will require large real estate, and maybe you don't have that. But more thoughtful, and hopefully integrating site-specific condition to design what we call a treatment train. So you'll have this unit that will treat for, I don't know, cyanide, then this other unit will, the water then goes to another and will treat for nitrate, and then it'll go and get denitrify, or, and then you'll have a unit maybe perhaps that will treat for selenium. So it'll be more of a train. It will be adapted. It will be site specific. I don't think in 10 years you will see as many off the shelf, let's all get high density sludge, let's all get this, and you buy it off the shelf and you install it. I don't think you'll see that. You will see water treatment systems that are adapted to the water quality that you have and the water quality criteria that you're trying to achieve by incorporating various different types of technology in different orders. It's not true that you always put one before the other one. It depends on what you're trying to achieve. And more research in that domain. And also, I'm hoping that what we'll see is people thinking outside the box. Don't be afraid to use something that's different, to use something that's new. Maybe you do it alongside something that's better known, and then you can transfer to that one. And hopefully our friends from the regulatory department are going to accompany us on that as we develop more and more effective ways and often different ways of treating water effectively.
Okay, that makes a lot of sense. I'll take a question from the audience. We have here one for Dr. Sylvie from Sandeep, and he's asking, please inform if there is any collection of baseline environmental data for a better water management later. So I guess just referring to the process of implementation.
The more information that you have on your source term, which is what's upstream from what you're doing that may impact on your water quality, the better it is. The more information you have on groundwater seeping, on surface water entering your system, the more monitoring data, and for the longer you have, the more precise you'll be able to develop a water treatment system that's going to be particularly adapted to what you're trying to achieve. So the more baseline, the better.
I have here a pretty technical question. It's for Dr. Simair, and there is an audience member inquiring about the many uranium mines in Ontario, and they would like to know, about permissible limits for uranium-238, thorium-232, and radium or radon 226 in discharged water from mines and mills. Do you have any comment on that? That seems pretty specific.
I actually did one of my postdocs at a uranium mine. So it was on subaqueous deposition of uranium tailings and how to keep things from not mobilizing. So that comes right after my heart. That's wonderful. Those specific guidelines, they do change from time to time. I tend to refrain from commenting on specific guidelines because that's the range of the CCME. And in this case, when it's nuclear, it's also the CNSC. So there's two layers there in addition to the provincial regulations that you'll have. They will be changing, and they do change over time. So I just say keep an eye on that. There's some really neat technologies to remove both radon, radium, and uranium. Uranium itself is one of my favorite things to work with for treatment because it is one of the elements that is redox sensitive. So you can work with it in bioreactors and stuff like that. But the actual guidelines, I would just say refer to the CCME and the CNSC, because you will have a second layer there.
Okay, all right. Well, with that, we're running up against the time. I'll perhaps invite the panelists to make some concluding remarks, if you will. Let's start with AJ.
Yeah, thanks. I suppose that the way I would conclude is, I mean, as I was preparing for this, and we had a chance to have some discussions with Dr. Simair and Saint-Jean, I mean, I think with Dr. Saint-Jean's focus in water management and Dr. Simair's focus in particularly in things like semi-passive treatment and my own in active treatment, I really do see the challenge we have in mining today is to not just treat water, but to do effective water management from active mining through post-closure. And I think it's exciting for our generation, and it'll be a challenge for future generations too, to effectively, I think, and successfully do good mining and then do good mining closure. And I think it's the challenge and the approach to the challenge is right in the center of the Venn diagram for water management, active and semi-passive treatment. I really think, I'd commend the Northern Miner for bringing us together. I think this is the type of collaboration, this type of holistic review of those challenges and addressing those challenges is really the thing that we should be seeing as one of our key parameters for success in the future in mining. So, yeah, thanks.
Excellent. Dr. St. John.
Yes, building up on what AJ just said and thanking my extraordinary colleagues here and Henry for hosting us. Yeah, don't be afraid to think outside the box. Don't be afraid to try new things. And what really excites me is that I think we're at the cusp of changing a paradigm in terms of mining and the image of mining throughout the world. Whereas in the last 200 years, we've been, not known for the best corporate citizen, not known for being the best neighbors and taking care of the environment. We've done some pretty horrific things as an industry, but we're at the forefront now. We are changing the way we're doing things, and we're rapidly becoming the leaders into how we use water, how little we use it, how much we recycle it, how well we treat it, and soon we'll be the absolute industry leader in terms of ESG associated with water management. At least that's my hope, and I'm excited for that.
I guess it's a shared hope amongst all of us. And then Dr. Simair, some final thoughts from your side.
Yeah, well, it's sorry. Yeah, so thank you very much for having me here, as well as my colleagues. Someone just stepped into the unit as I was talking. But yeah, so thanks very much for having us all here. And it's I'm very impressed that water has become such a topic across all of mining. You'll find a lot of the things that we're kind of talking about today are things today, but also things that, like, what could it be in the future? And I mean, that's a theme of a lot of this session. And we need to look at that too, because when we're looking at even opening a mine today, we have to think not only what does the mine need today, but what does it need 10 years from now, 20 years from now. And when I opened my first business 12 years ago now, we were thinking of what could water treatment be a decade from now. And now again, we're saying, what is it going to be a decade from now? Because we need to be building those technologies now. We need to be thinking about them. We need to be implementing the seeds of those, the basic bits of it, because otherwise 10 years from now, they won't exist. And if we want to have more, what people are considering cleaner energies, greener energies, the solar panels and nuclear fuels and things like this, it's all going to require more mining. And we cannot be trading off our air for our water. So we need to be thinking about these things right from the beginning, and also thinking of it from the whole mine, not just how do I clean the water, but the things that get me really excited is, I mean, there's some closed mines that we get called in to help with, and that's neat because you can try things that maybe you wouldn't be able to try at a new site. But the new mines coming up that are saying, let's look at the whole mine plan from a perspective of water, because they know that's going to be their biggest long-term cost in perpetuity. And that gets me excited that the whole thought process is shifting and becoming that forward looking. My last company, I had the tagline of forward looking lateral thinking. And I think that really applies here for the topic of water. And thank you very much for having us.
That's a very hard-hitting slogan to work with. Lots to unpack there. I can tell you just the final comment from my side, Dr. Simair, there is significant interest from the audience, it seems, to have your services in Central America and South America. Quite a few people are asking for your contact details, etc. So just throwing it out there.
Awesome.
With that, that concludes our water management panel for today. Thank you very much, panelists. And with that, I'll send it back to you, Robert.